Opportunity to also share some of our work here. So this work is dealing with maybe one of our biggest issues in small fruits. I know it is an issue in California. I've worked with a lot of growers in California over the last 10, 15 years on this problem. And so what I'll share today is something that I've shared quite a bit with our growers here in Oregon. They're very excited about that. So I'll kind of explain what attract and kill means and how that fits into the cropping system if you're producing small fruits as well. So when we look at our berries, any berry doesn't just have to be a blueberry. What we as growers want to do is we're growing that berry and we're harvesting usually in this stage, usually not in the dark blue stage if we're looking at blueberry itself. But what happens during that process of ripening is really, really important. If we look at a plant, what this plant needs to do is it needs to protect that berry, and then that berry needs to ripen, and that berry needs to be attractive to, let's say, plant-eating insects. We also now, as human beings, are using those plants. But when we're looking at that ripening period of the berry, this plant cell wall consists out of various structures that protects it. It includes hemicelluloses, pectins, and other compounds. As the berries ripen, those compounds start breaking down. They start mixing with some of the compounds deeper in the berry, and there are volatiles that are being released. So what I'll share with you in this talk is explaining to you how we can use those volatiles to produce our crops without using or with using less toxicants. And so when we look at Drosophilla, this is, you may have seen this egg laying process. The problem here is when the egg is laid, then the larva will develop inside the berry, as you can see here. It'll pupate, and that developmental phase is what results in the berry eventually not being marketable. So I'm not going to go into too much detail of that at this stage. There are various ways in which you can manage this process, especially in the packing shed. A lot of our growers are using cold storage, and even with eggs laid and even with larvae developed, as long as that berry is firm enough and you're cooling it down adequately, you are going to have a high quality berry. So this is kind of a slide that I just showed to some growers down in South Africa recently. These are the berries, the berry types that are affected. Some of them are not listed here. Figs could be a host as well. But when we're looking at suitability, the softest berries, these raspberries, strawberries, blackberries, those are really, really good hosts, as opposed to blueberry and wine grape, which are not quite as good hosts. And very often that is because of the firmness of the skin. So the softer the skin and the higher the sugar levels, the higher your chance of having damage in those berries. If you look towards the bottom of your slide here, you will note that there is an extension service document number. That is one in a series of 10 documents. So if you look up that document, you will be able to find that document plus another 9 documents, which largely talks about the different management techniques, some of them also being cultural techniques as well. So if you have a minute, just write that number down, and that'll take you to all of the additional documents itself as well. And so initially when Drosophila arrived here in Oregon, our growers really spent a ton of money getting the right equipment to spray. This photo was taken in the early 2010s. At that stage, growers, there was an absolute no tolerance for Drosophila, and growers were spraying as many as 20 times per season. Not only were they spraying, but every time when they went through the field, that machine would knock off around $1,200 to $1,600 worth of berries. And so if you're spraying 10 times, let's say, that's 1,600 times 10 that you're losing because you're knocking those berries off. One factor that we don't always take into consideration. The other big issue, especially in the early days with these sprays, were uh, residue levels. So if this was exported to Asia or other parts of the world, sometimes those levels would be exceeded and the crop would be rejected. So really, real important for us to make sure that we take into consideration the residue levels when we use toxic sprays in the field against Drosophila. Just another informational slide. You'll see that there is, this is also one of those OSU extension documents, 9261. And this explains to us, and this graph on the left-hand side here explains to us the structure of the insect population. So yellow is, these are our adults. And so here in Oregon, not so in California, but in Oregon specifically, we know we have mostly adults in the field. As the temperatures increases in February, March, those adults will start laying eggs, which is indicated by red here. Those eggs will be laid in berries. They'll develop into larvae and in pupae. And you have what's called a stable population structure. And so when we look at California, you will essentially find this structure, let's say from April to October, through a much bigger part of your season. You're going to have adults continuously emerging out of berries in the warmer, milder areas, and you're going to continuously be fighting this problem through the whole season, depending on the diversity of your crops. If we look at the right-hand graph here, this shows, and I apologize for centigrade, follows a very, very predictable curve. Drosophila does really well in the mid 70s into the mid 80s. Anything above or below that, below the temperatures will result in the insects not developing. Above, the same thing. And in some cases, it'll result in mortality in both those scenarios itself as well. So those temperatures in the mid 70s to mid 80s, that's when we really tell our growers to be concerned about it. So just to talk a little bit about other techniques, I just talked about the pesticide use. I know some growers use mass trapping. You know, people will place out hundreds of these traps in the field, and they feel that, you know, when they trap 500-600 flies on a weekly or a daily basis, that this is reducing the problem. We don't have much evidence showing that that works. Two other technologies that are being looked at, gene-edited flies, you know, sterile flies that are released. Some people are starting to look into that. It is a technology that has many benefits. It's non-toxic. It is very specific as well. So maybe in future this will be something that will be available to some of our growers. However, it's kind of unclear as to what the cost for that would be. I think organic growers are very interested, excited about biocontrol agents. Some of our scientists in California, Frank Zalem, Kent Dane, and others have been working on parasitoids that are being released in California itself as well. And I know that some growers are using nematodes as well, and there is some promise regarding some of those nematodes. And so, in addition to these specific control methods, there are other things that you can do as well. When we look at the actual sprays, There are now various adjuvants that some growers can use. Organic compounds include sterilants. One of the favorites here in Oregon is Jed Ag. It's a sterilant that growers use for sterilization on the leaves, but it also affects Drosophilla itself as well. Um, Also, there is a new oil that we just tasted this past year. It's a product that is produced by GrowPro. It's called Wrath. I think Wilbur Ellis will stock it in future. It's essentially as good as the very best organic compound at this stage, with spinosyn classes, Entrust being the compound that most organic growers know well and use carefully when they're managing this insect. Um, we have also looked at other methodologies. Some growers use these nets, these protective coverages, which works really well. Pruning helps a little bit, but none of those techniques are really standalones. I just talked a little bit about refrigeration. Refrigeration is maybe one of your most useful tools. What a lot of growers do is when they harvest the berries, they will firstly make sure that those berries are firm. If you have any eggs or larvae in those firm berries, and they're put straight into refrigeration around 30 to 32, 33 degrees Fahrenheit, those berries will maintain their quality for as long as an unaffected berry. So the quality of those berries will be very, very similar as as berries that have no infestation. This was the slide we looked at a little bit earlier. And so I want us to focus just on one or two compounds here. The go-to compound that many growers use is the one right here in the middle, spinosad. Problem with spinosad is that it is the only compound, the only really good compound that organic growers are able to use. There is some evidence that there is resistance development in California specifically, and so we have to be very careful when we use those. The way that we use spinosad in Oregon is how I will show you in some of the upcoming slides itself as well. There are quite a few other compounds that you can be using, but not as an organic grower. Not on this slide. Spinosad always is the go-to compound. The other compound that I mentioned a little bit earlier is this black one, peroxyacetic acid, which would be the sterilant itself. You can use neem and pyrethrums and so forth as well, but if you compare that with the red bar of spinosad in the middle, I would say less than half as good as spinosad at this stage. Okay, let's look a little bit at how we as human beings have changed plants. So if we look at this slide here, you have an aphid and you have these spines, these trichomes on the surface area. And so this is a mechanism that nature has to protect the plant. And what we've done as human beings is we've bred that out of our plants. So if you have a blueberry, it needs to be nice, big. Blueberry needs to be sweet. You don't want it to have, um, uh, undesirable taste or flavor or anything. It needs to be just absolutely perfect. So we don't have those factors that hold the insect back, that prevent the insect from causing the damage. And so what we now as human beings need to do is we need to protect those plants, right? So let's look at some of the ways in which we can do that. This is a tool that is now used very extensively in California, Mexico as well. This is a technology that we've developed at Oregon State University. It's called Decoy. It's a product that we developed here in our lab. So how does this work? What this does is it is a product. If you look at the bottom left-hand slide photo here, you can see the fly right there with that tablet. It's a little tablet that produces volatiles very similar to what the berries produce. And so instead of the insect going to the berry and causing damage on the berry itself, it'll sit on that, it'll feed on that, and it'll protect the plants against that against the insect damage. The product itself needs to be watered, and so luckily in California, people use drip irrigation and so forth. So you have these little dispensers that are applied at 50 per acre, and they last about 3 weeks. So you place around 50 of those out, last around 3 weeks. It can be used on its own. It can also be used in combination with pesticides such as Entrust. So on the graph that I'm showing you at the top here, and this is Oregon data, my apologies for that, that it's not California data, but this is a late variety crop here. I think this is Aurora that we have here. And so if we look at the solid blue line, this is untreated control. The red line is the treatment with the product that we developed here, which is the red line. And then the blue, let me just make sure I have this correct here. Red line is the gum, and then the green line or the yellow line is the grower standard. And so you can see from this slide that it's not quite as good as grower standard. With grower standard, we're talking about compounds like Entrust being used, peroxyacetic acid and Grandivo and others. But what I want you to look at here is the y-axis. So the y-axis in this graph gives you an indication of the pressure or the damage on the berries. So if we look at 0.01 here, we're finding approximately one egg every 10th berry towards the latter portion of August when we're looking at the untreated control. There is no grower that have ever produced berries, in my understanding, at that level of infestation that had any rejections in his orchard or in his field. We are looking, if we're looking at the grower standard and the gum or the decoy, we're looking at levels below 0.05 towards the latter portion of the season. So we're looking at maybe one egg every 20 berries, which in my understanding is it's a good quality berry. You can harvest it, you can market it. If you're putting it in cold storage, you should be fine. Okay, so finally, we're going to talk a little bit about attract and kill. So this is a technology that has been used and still is being used all over the world, also here in America, um, to increase our ability to apply compounds very quickly and apply those compounds at relatively low pesticide concentration levels. But before we talk about that, I want us to just look at EPA recommendations. So this is taken, this text that I have, this boring text, taken directly from EPA's website, specifically talking about those Section 2 EE recommendations. What does the Section 2 EE recommendation state? It states that if you're using a toxicant, so remember we're talking about attract and kill. So let's say you're using something like decoy, something like Combi Protect, you're attracting the insect, and you have a kill portion is in it itself, and that is where this dosage comes in. So when you are tank mixing your attractant with your toxicant, what Section 2EE tells us is that if you apply that tank mix with the toxicant in it, you can apply that toxicant at any dosage or concentration or frequency less than that specified on the label. And it's underlined here, it very clearly states, unless the label specifically prohibits such an application. So if the label does not specifically prohibit such an application, you're fine. If you're using a compound like Entrust, that is not a problem. If we go to the bottom of this text here, you can apply that toxicant, that tank mix, using any method. You can put the tank mix on the back of an ATV, you can put it into a drone, you can apply it on the ground normally as you would with an air blast. Various options are allowed. And so how does attractant kill work? So if we look at bait spray on the left-hand side here, we're looking at volumes, anything between 2.5 and 5 gallons an acre, 20 to 40 liters of volume per hectare. If we compare that with full cover application, we're looking at around 10 times higher. If we're looking at quantity of insecticide used, we are looking at 3 to 10% of a standard insecticide. So as an example, we're looking at Entrust, you're using 6 ounces per gallon of Entrust. When you're doing a bait spray, you're doing 0.6 ounces or less. You could be doing 0.2 ounces of Entrust per acre. So your toxicant is reduced at least 10 times um, than a full cover application. So what this allows us to do is it allows us to reduce our quantity of active ingredient, our toxicant. What we're also doing is we're not doing a full cover spray. You're not covering the leaves, the fruit with toxicant. You have tiny little droplets that make up anything between 3 and 8% of the whole canopy. And so you have at least 10 times less residue on your berries. And in theory, the thought is that you're going to have the same efficacy. Another advantage is when you're using this type of technology, why growers love it, is you can do pretty quick applications. We're looking at, when I show you the video in a minute here, we're looking at around 1.5 to 2 minutes an acre application time. If you look at the drone that we're going to play the video of, we're looking at around 20 with fill-up times and so on. We're looking at around 20 acres in an hour, more or less. Okay, I'm going to share with you a little bit on the biology of the insect here. And this is lab work and kind of showing you how attractant kill compares to an untreated control. And so what we did here on the left-hand side, on both of these graphs, is we applied droplets, not directly on the berry, containing the toxicant and the attractant. We tested 2 attractants, the one that we just mentioned a little bit earlier, the OSU one, and another commercial attractant, which is called Combi Protect. And so when you're looking at the number of eggs laid per berry, we're looking at least a 50 to 60% reduction in eggs laid per berry when we're using these attractants. That's without spraying anything on a berry. So you would think that when we see this type of thing in the lab, that would carry into the field. Right-hand side here, we're trying to look at the opposite. Are we killing these flies? Are the flies feeding on that toxicant? Are they taking it in? Are they dying within a 24-hour period? And what we're seeing, if we're comparing to an untreated control with no dead flies, that we're killing around 10 flies within a 24-hour period. with the OSU attractant and 3 or 4 flies when we're looking at the other commercial attractants. So the data looks really good here. This is statistically different. Let's show you some of the data from some additional trials. We're looking at these field trials as well, which is not quite the full open field trial. I'll show you that in a minute itself as well. Middle portion here shows you what the arenas looks like. We also had these activity trials where we looked at the fly activity. Did the fly go to the stimuli and stay at the stimuli, which is indicated as dwell time? And dwell time is really important when you are applying an attractant kill. We want as high a dwell time as we can. We want that fly to be attracted to the attractant. We want it to stay there, to take up the toxicant and die away from the berry itself. So let's look at another set of data which kind of shows us the dwell time. On the left-hand side, same thing as we showed earlier. We're finding way less damage on the berries when we look at various attractants. When we look at dwell time, specifically if we look here at attractant B, which is one of the commercial ones, we are finding a very high dwell time compared to water. So another way of looking at the data, we're showing that these insects are not going to the berry. They are being pulled away from the berry and they're being killed. Okay, another set of data here talking about eggs laid dependent on droplets. So remember, we are applying a lot of droplets. We wanted to see, does number of droplets play a role? We need a decent number of droplets, is what we see from this trial on the left-hand side here. And so we are looking at rates in the field of around 5 gallons an acre at that 10 times lower toxicant rate when we're mixing it with the attractant. This is the type of thing that you would literally find out in the field where you're reducing your eggs on the berries and you are killing your flies. An example that I show here is with malathion. With Entrust, we are finding very, very similar results to this. Semi-field trial. This was done in at the Oregon State University Lewis Brown farm. We had 2 trials last year in late berries. And when we compare our untreated control to our attractants, the data look actually quite good. We were finding around 78 to 80% reduction in damage in both of these cases, in both of those trials. So that data bodes well for attractant kill. This slide shows data from work that we did in open field. This is in blueberry, Aurora blueberry, where we compared full cover spray, which is the green line here. Our attractant kill is the blue line. And then we had, what was the third one? The full cover attractant kill. Actually, this was a higher rate of attractant kill. What this data shows us is that we're getting more or less similar results to a full cover spray. So this was our first data that we generated in 2023. And so if you look at the y-axis here, we're looking at maybe one egg every 10th berry, which is below threshold for harvesting berries. This is what our trial site looked like. One of the trial sites that we looked at this past year here in Woodburn, in the northern Willamette Valley. What we did is we had repeated measures. We had 2-acre plots. We were using drones and applying the mix, which I've shared some of the details with you a little earlier at 5 gallons. Our concentration in this case was 1/10. 1/10 of toxicant. I think we were using around a pound of attractant within that 5-gallon mix. We were sampling in the field itself 120 berries in each of those plots, evenly distributed through the plots, and we did that twice a week. And so we would bring those berries back to the lab, look at them on the day of collection, and send the data back to our growers to tell them what the data looked like, helping them decide whether they're going to go and do a full cover spray, whether the attractant kill is working or not. In this case, we were using an XIGP 100 Pro drone at this organic farm here in Woodburn, Oregon last year. And so our treatments, attractant kill, buffer is essentially the same as a grower spray. It's a full cover spray for growers, which is done here in Oregon at anything between 50 and 80 gallons per acre, more or less, at the rate of, if we're looking specifically at entrust, around 6 ounces per acre. So both buffer and grower standard is essentially a full cover spray. The attractant kill is sprayed at the rate that I just showed you, just explained to you a minute ago. So here we have the drone, sorry for the noise, taking off. And so the goal with the drone is to create these droplets. It's set, the nozzles are set at 0.5 millimeter, I think it's 1/16 to 1/25 of an inch in diameter. So what this drone is going to do now, it's going to go to the edge of the field, and it's going to go around the corner where you can't see it. It'll apply at that rate very accurately, and this is what your droplets would look like. You'll see it going from left to right on your screen, applying at that rate, and you'll see it stop spraying kind of midway through. It was programmed to stop spraying because there's a road, little passageway in between there. I think it's stopping. Now it's going again. Close to the edge on the other side. Automatically stops spraying, goes to the next swath, and then applies in the next swath itself as well. So as it comes back, you'll see it stopping again.
There it does it. Yeah.
And so this is, in my memory, is around 1/4 of an acre that was just applied here in that time frame. So I think maybe it was a little bit more than that. So here's the data. As I said, we were sampling twice a week, and in the grower standard as well as in the buffer, our growers applied entrust twice. Every time where we see this green dotted line, 2 applications, full cover applications at 6 ounces an acre of entrust. For the drone sprays, we did 4 sprays. We were really nervous and we did not want to take any chances, so we sprayed 4 times. And so that equates to 2.4 ounces in total for the 4 sprays, as opposed to the 12 ounces per acre for the 2 full cover sprays. So still much lower than a full cover spray. So let's look at the data here. This is your buffer, black, and your grower standard green data. This is again eggs per berry, so we're looking slightly higher pressure than the slide I showed a little earlier. We're looking at around 1 egg every 3rd berry with both the grower standard and the buffer. So our growers in this case, again, good quality crop, taken into the cold room pretty quick after harvest, no issues with any rejections. Comparing that to our attractant kill, Numerically slightly lower in the attract and kill plots. Statistically, exactly the same thing. We're looking at no statistical difference, maybe a slight numerical difference. One site. Second site that I told you about was the one that we did in 2023. I will show you one additional site. We did 4 sites this year, and they all showed very, very similar results. So the plot that I showed you in the video a minute ago, our grower specifically wanted us to do the attract and kill in the high pressure plot, and this is the data that goes with that. So what this tells us is that the lab data is carrying through to the field. We are seeing a very, very similar result irrespective of the concentration of the toxicant and the method of application. Here we have another example, another plot. This was also late season. This is typically when this was not a very high pressure season. Again, open field, no significant differences. In this case, the grower applied Entrust 3 times. And if you look at the peaks here, the uh, the red line, this is attract and kill. Every time when we would find something like 1 or 2 eggs, we would tell our growers to do an application. You can see how the numbers go down. Again, this was high pressure plot in the attract and kill. Again, the pressure highest scenario was in the buffer, and the attract and kill, kind of the same thing at 0.2 eggs. Or how can I put it? 1 egg every 5th berry, more or less. Again, no issue whatsoever with any crop damage or so. In this case, 3 applications with Entrust close to harvest as opposed to 4 applications with the drone sprays. And so still very, very comparable, maybe slightly different cost. So overall, when we look at this data, our growers are kind of excited about that. We're going to expand this work this next season. This attract and kill technology is available commercially for our growers here in Oregon itself as well. And so our growers are going to be expanding the use of this. This is in addition to some of these other techniques, that I talked about a little bit earlier. We've shown with this work now that we have at least 2 attractants. One of them is a German product, Combi Protect. The other one is a product that we developed here at Oregon State, Decoy. We are seeing from our data that we have crop quality as good as full cover sprays, and we're doing that with 1/10 of the toxicant. And our belief is that our toxicant is very targeted. We are able to target our pest insect very efficiently because it's attracted to the toxicant instead of the full cover spray where the insect accidentally lands on the toxicant. We believe that this is a very useful resistance management tool. We've got some trials going on to kind of illustrate that itself as well. In certain situations, especially with bigger operations, we believe that our growers can save a lot of cost and time. One of our concerns is regulations using drones. We've got quite a few possible regulations that could hamper our ability to use drones like this. That's maybe one of our biggest worries at this stage. And so that's a quick summary of, I'd say, some of the newer stuff that we've got for this specific insect. If it was very specific, I apologize for that. Mercy wanted me to talk about that, so I decided to do that. Before I finish, there's a Qualtrics presenter survey on the right-hand bottom corner there. If you do that survey, I guarantee you it will not take you 30 seconds. It'll be pretty quick. It's a very painless survey. I can then share that with my department head and our deans, and show them that we're doing work that's relevant to our growers. So very much appreciated the time that I was able to share with you.